Some people say did well, very good. Others, some people not responded in class, but they are writing well. That means they may know about the concept, but not responding in class, right? Okay, Manoj. Yes, Yash, we need to improve. Yashvin, I have one suggestion for you. Try to improve your presentation, Yashvin. Okay, not clear. Okay, try to improve your presentation and write. Give some better way. Okay, really, some people are presented well, and topics also explained very good. I am really satisfied with some people. You will please, you can check with that with like Miha wrote well. You have impressed so much with that paper. I'm satisfied with that data structure concept and um, my lecture. Yes, pa. Yes, Isak, you have to focus on concept. Miha, have you checked your mistake in that particular heap problem? Yes. Okay, fine. Ramya also did well, and boys, some people also did well. I mean, presentation. I forgot the names, but some students give very good presentation and explain well. I don't know whether some people, I can understand. Some people are copied, some people are did their own. I can differentiate, but no need to express here. Please try to prepare well and do well. Okay, with the copying, no need. Okay, with the copying, no one get use of it. You will lose. Okay, please prepare well and try to give your performance better. Okay, some people's are really good presentation and concept wise also I impressed. You never forget this particular data structure concept. Okay, thank you. Okay, we will move to our fifth unit. 5th unit is nothing but it's talking about searching, sorting, and hashing technique. Okay, this is our syllabus. 5th unit searching. You already studied in C language in the previous semester, right? Linear search, binary search. Is it so? Yes, yes. Okay, fine. And in the case of searching, we are going to discuss about linear and binary, then sorting algorithm. Okay, sorting nothing but arranging elements, right? For that, we have some methods: bubble sort, selection, insertion, cell sort, and radix sort. Okay, these are the sorting algorithm we are going to discuss. Next one, hashing function. Hashing function is nothing but is for indexing. Okay, in the case of B tree, I have explained, right? What is by indexing and hashing. The indexing is nothing but this is a hashing technique. Okay, we just refer one table with the help of some value or with the help of some function. This is the hashing and hash functions. In that we are going to discuss three more topics, sorry, three more methods to implement the hashing: separate chaining, open addressing, rehashing. Okay, these are the topics we are going to discuss. Interesting one, interesting unit. The compared to the previous unit is somewhat small unit only. You can complete within 3 or 4 hours. Okay. The searching and linear binaries already you know known, so no problem. I no need to explain more, right? What is searching? Searching is the process of finding some particular element in the list. Okay, searching is nothing but it is a process of finding some particular element in the list. Okay, if the elements are arranged in some manner or method or alphabetical order or ascending order, then it will be easy to search. Okay, for that purpose only we are going to the sorting algorithms. Okay, now we are discussing about searching. The main purpose of data structure is searching, right? Why we are using the concept of data structure? Just arranging the elements, right? So with the help of this we can arrange the element. Once we arrange it, then we can easily pick the element from our list or from our storage or from our shelf, anything it may be. Okay, so main aim is searching. Searching is nothing but is a finding particular element in the list. If the list is arranged in alphabetical order or some anything some order, then it will be easy to pick the element or pick the data or pick anything from the list or array. Okay, so if the element present in the list, then the process is called successful and the process return the location of that element. Otherwise, the search is called unsuccessful. Okay, this is the definition for searching. Searching is nothing but finding an element. If the element is present in the particular list, then the particular process is successful. Otherwise, unsuccessful. Okay, then tell me what is my linear search and what is my binary search? Yes, what is my linear search? What is meant by linear search, ma? Searching sequentially in linear search. Then tell me what is my binary search? Yes, Ashwin, searching element by element in sequence order. Yes, very good. And what about yes, yes, very good. Splitting into half is divide and conquer method. Okay, this is the difference between linear search and binary search. Okay, how we can implement? For example, how you can write a program for linear search? We just go with the for loop, right? Each and every element we are checking and finding the element. Particular key is equal to searching data. If it is true, then we can come out the particular element is present and display something. Otherwise the key is not present. Okay, this is the linear search, right? We'll see one by one. Linear search, otherwise called as for another name for linear search is sequential search. And linear search. A linear search, also known as sequential search, is a method of finding an element within a list. It checks each element of the list sequentially until match is found or the whole list has been searched. Okay, if the element is found, until they are iterating the process and finding the element. If the element is not present in the list, then we have to travel and search until the list is over. Okay, so this is one of the simple approach. Begin with the first element. Okay, leftmost element of the array, I mean array of 0, and one by one we are comparing and finding the element. Okay, if the access matches to any element, and return the index of the particular element. Okay, which element we are going to search, that element is present, then we can return the index of the particular element. Otherwise the particular program may return -1. Okay, the same thing only here explained. This is the way we start with the 10, the element 10 and 5, 15, 20, 25 and 35. This is the way we can travel. Okay, this is called linear search. Okay, what is the implementation step? Traverse the array with using a for loop. Okay, this is the concept. We can use the for loop. With the help of for loop we can traverse the whole list. Okay. In every iteration, compare the key value with the current value of the array. Key value is nothing but the element which we are going to search. Okay. And current value is nothing but elements in the array. If the values matches, return the current index. Otherwise, do not match, then move on to the next element. No match in the list, then return the -1. This is the routine for that particular linear search. Okay. We just given that one for loop. With the help of this, we can travel through the list. That's it. In that for loop, we check one condition, particular value of I equal to key. Key is nothing but the element we are going to search. Okay. The value of I is nothing but the elements in the array, whole array. Values of I. It moves, it travel up to the n value. Okay. If it is present, return I. I is nothing but here the index position. This is the index position. If the element is present in the particular list, then it return the index position. Okay, here this index will return here. Otherwise, return -1. Okay, this is a small routine for linear search. Please go through this routine. With the help of this only, we can develop a program in the next part 12, 13, 14, right? And that we are going to implement this concept. This is called linear search. Okay, where we can use the linear search means if there is no information is given about the particular array, just give one array and it's going to search element. No information, no prior information about the particular array, then we can go with the linear search. Okay, the given array is unsorted or the elements are unordered. Okay, in this concept, in this way also we can use, that is, the array is unsorted, the given array is not in ordered manner. Okay, then we can use the particular linear search. Okay, the list of data item is smaller. Okay, the elements, list of element is somewhat smaller. I mean, it may have, it may have 5 or 10 elements. Okay, if it is having thousand and lakhs of elements, then it is not possible. Why means we are moving one by one, right? We have to travel all the elements in the list. Okay, so that we can use that particular linear search for the larger elements. Okay, if it is the elements are smaller, then we can use. Okay, this is a program for implementing linear search. I will upload this program in Google Classroom. Please refer and try to run this program. Just what they are doing, just printing how many elements, asking, and get the elements. In that, which element we are going to search, like that they enter the element to be searched. Okay, the user need to give one element. How they are searching? With the help of for loop. Checking in that for loop, they are giving one if condition, a of I equal to x. X is nothing but the element we are going to search. Okay, if it is matches, then return element found at index position, like that. Okay, here just checking the index is within the n number of elements or not, like that they are checking, and the element is not found, then returns. A simple program. With the help of this, we can implement the linear search. Okay, we can give at most you please try to give with 30 elements or 20 elements and try to search a element from the list. Okay, this is a linear search. And discussing about time complexity. If the element we are going to search, it is present in the first position, I mean array of 0, then it may take the best case. Okay, it may take the time to find the particular element is order of 1. Is it clear? The element we are going to search is present in the first position, then we no need to go for further, no need to go with the further iterations, right? Already found the element in the first position, so it may take the time complexity is order of 1. Otherwise, worst case, in the case of worst case, the element may be present in the last position, then we have to do with n number of iterations, so it may take order of n. And so if the element is not present in the list also, then also we have to go with n number of iteration. We have to search up to last element, but the element is not present. Okay, but even though we have to search with n number of iteration, that case also it may take order of n. So the time complexity for the linear search is order of n. In that best case we having order of 1, worst case we have order of n. So we can say it is an order of n. We have to make the, we have to take the what maximum one. Okay, almost within this order of n we can search. Okay, this is the time complexity. And advantage and disadvantages. Linear search is simple and very easy to understand and implement. It does not require the data in the array to be stored in any particular order. Disadvantage of linear search: slower than many other search algorithm. It has a very poor efficiency. Okay, it taking more time because it's searching each and every element, right? So it taking more time, and it has a poor efficiency. And next one, binary search. Binary search is nothing but it's a concept of divide and conquer. Okay, we are just splitting the element into list of elements into two. Okay, then if the element we are going to search is less than the particular middle element, then we go with the left side and otherwise right side. So what is the difference? Here we have to go through only the list of not in the all the elements in the list. We just compare the searching element with a minimum number of elements. Okay, for example, if we are having the 7 elements in the list, then we have to divide the particular element into two parts, left side and right side. The element we are going to search is less than the particular element, I mean search root element, then we go with the left side only. No need to go with, no need to search with the right side. That means it is in the form of binary searches. What's the difference between linear and binary? It is in the form of order. Okay, ascending order or some in any other order. Okay, binary search, searching element is sorted array. Okay, in the case of linear, not sorted, a sorted array, so that we can find the element in quick manner. So it is called runtime complexity is order of log n. Log n is nothing but once any one of the program following the concept of divide and go with half of the element, then you can say blindly, you can say this is the runtime complexity. Okay, no need to go with n number of elements. Okay, logarithmic of n, we have to pick list of element from the array and going to search or going to do process. So it is the time complex order of log n. Binary search works on the principle of divide and conquer. This searching technique used for the particular element by comparing the middlemost element of the collection. It is useful when there are large number of elements in an array. Linear search is used for smaller amount of elements, and binary is used for larger amount of elements. Okay, if we are having 100 elements, then we can divide it into two parts, and if the element we are going to search is less than the root, not a root, middle element, then we can go with the left side. Okay, we can go with the left side and search element. Otherwise go with the right side. Okay, no need to go with left and right. So it takes lesser time than linear search. This is the way we are going to search element 25. Okay, for that here how many elements is 7 elements. We can divide the particular element into how we can divide index. This is the index. What is the index for the element 5? 0, right? This is the 0th index. This is 0, 1, 2, 3, 4, 5, 6. Okay, so we can find the middle element by 0 plus 6 divided by 2. Okay, That's the way we can find the middle element. 0 plus 6 divided by 2. This is the index. So what is the index? The answer is 3, right? The answer is third index is a 0, this is a 1, this is a 2, this is the 3. Okay. So this is the third index, and keep this third index is the middle and divide the previous one in the one part and the next one is the next part. Okay. Now we are going to search element is 25. The particular 25 is greater than 20. That is the middle element. Then we can directly go with the right side. No need to go with the left side. Okay. Again, here also we are no need to go with each and every element. We just doing the same process. Okay. Divide the elements. Three elements. So this is one is the middle element. 30 is the middle element. We can just divide that into two parts, 25 and 35. Again check with the middle element. 25 is lesser than 30, so I can go with the left side of 30. The element is found. Is it clear? This is the binary search. Here we have three cases. The element is being searched is found to be the middlemost element. Okay, the element we are going to search in, we are going to search particular element is the middle element. Then we can directly check with the middle element and return. Otherwise, the particular element is greater than the middle element, then go with the right subarray. Okay, the element is lesser, I mean smaller than the middle element, then go with the left subarray. Okay. Okay. The iteration keeps on repeating on the subarrays until the desired element is found or size of the subarray reduces to 0. This is a binary search. Start with the, in the case of linear search, we are start with the first element, right? Here we are going to search, start process with the middle element. The same case only here explained. Okay. This is some routine for that binary search. We have to find the max value, number of elements, and min equal to 0, just using one variable. This is nothing but it is using for finding the middle element. This min max is just for number of elements, calculating the number of elements, whether the particular list having some elements. Okay. For that, they are using the min and max. Yes, the max is greater than min, then we can go with that particular condition, max plus min divided the middle element. For that, they are using this variable. And target is nothing but is the element we are going to search. The particular target is equal to the value of guess is nothing but this is the middle element. If it is equal to middle element, return the particular guess. Okay, guess is nothing but what, index of the middle element. And otherwise, if it is a greater, the target middle element is greater than the element we are going to search, then we go with the max equal to guess minus 1. Guess is nothing but what, middle element minus 1. Okay, go with the left side, otherwise go with the right side. Okay, this is the right half, is the left half. The simple routine to implement the concept of binary search. We're just calculating the max value and min value, comparing the max and min to find the particular list having any elements or not. If it is having any elements, then we go with the particular binary search. That means we are just finding the middle element first. Okay, after finding the middle element, we are checking with that element we are going to search same, then we just return the index of the middle element. Otherwise, go with some condition, else if values of guess greater than target. Okay, that means this is the element we are going to search. Here we are going to search that element is lesser than the middle element. Okay, lesser than the middle element means we just go with the left sub array, otherwise go with the right sub array. Okay, this is the routine for implementing the binary search. Is it clear? It's a simple program only. The time complexity for that already I have explained, that is the log n. Okay, that means we just take, not taking the whole elements to process the request. We just, in that we just picking the sub array and doing process. So this, it may take order of log n. If it, the particular element is greater than the middle element, go with the right sub array, otherwise left sub array. Okay, this is a simple program, C program, to implement the binary search. Already you may studied in C language previous semester. Just taking the elements, enter the number of elements, and getting all the elements. Okay, and enter the value to find, enter the element to search, and getting that element and finding the middle value. The middle is while first less than or equal to last. Okay, just checking the condition. And if array of middle is here only checking that particular element is equal to middle, sorry, less than or greater than. Okay, array of middle is less than search, then we go with the what, the search element is greater, so we go with the right subtree. Okay, that is middle plus 1, first equal to middle plus 1. Plus 1 means we go with the right sub array, otherwise we have to go with the left sub array, middle minus 1. Okay, here they are using this concept, you may go with any other concept, no problem. Then advantages of binary search. What is the advantage? Binary search has to be arranged in sorted list. Okay, when we have the sorted list, then only we can go with the binary search. The algorithm is faster compared to the linear search. Yes, somewhat faster, right? We no need to go with all the elements in the list. We just pick the elements, part of the element, pick the part of element, and doing search. The number of comparison is less in binary search compared to the linear search. Yes. Then the binary search algorithm first finds the middle element and then searches the element position. So because of this, binary search algorithm is first find the middle element and then searches the element position. So because of this, there is considerable reduction of the element list. Yes, no need here telling that no need to go with all the elements, I mean all the comparison, all the iterations. We just picking the elements and doing that process. And what is the disadvantage? This is works only for the sorted list. Okay, but if we are having the list with unsorted, then we can't go with the binary search, we just go with the, we can go with the linear search only. Is again here another one thing, the worst case and best case are nearly same for the binary search, but in the case of linear search, best case means order of 1, worst case means order of n. Okay, here if the element, particular element we are going to search is present in the first position, array index of 0, then how we can do, directly we can go with the and doing the process. So it worst case and best case also it having the same amount of time. Okay, it's a difference. Please refer this, just saying the difference, random order and sorted for a small list and large list, low, fast. Okay, advantage understood. What is that much simpler than binary search? Okay, please refer this. Just differentiating the linear and binary and advantage and disadvantage. Okay, with the operation of arranging a set of data in some given system is nothing but what? The element should be in one order. It may be numerical type of shorting. Yes, my voice. Now it's clear, pa? Isa? Yes. All are following? Okay, pa. Is all are following? What is Miss searching and linear search and binary search? Very, very easy topic only. Yes, respond me, all of you following? Yes. Okay. Please, one trick I want to tell you that if you are any subject, it may be, if you are clear with the fifth unit, then you will definitely get full mark from that fifth unit. That means, in the case of fifth unit, they are asking only the, they will asking only the particular what important question only. Okay, but in the case of first unit, second, you are very much familiar with first unit in all the subject, right? But they are asking some difficult questions in the first unit. But you are in the fifth unit, you are talking about fifth unit. You just go through the important topics, then it will be the question will come with that important question only. Okay, the question paper you may expect the important question in all the subjects. So please concentrate on the fifth unit. You will get 3 marks plus the 2 marks also. All are you please refer with any of the question paper. In the case of fifth unit, they are asking the familiar topic only. So concentrate, all of you, in all the subject. Concentrate on the fifth unit. You will definitely get almost 15 marks. Okay. Okay. Type of shorting. We have two types: internal shorting and external shorting. Now you know, right, what is searching in linear and binary search, two types, linear and binary search, and what is linear search. And in that you have to explain the steps and algorithm means our routine or program, anything. You can go with any one routine or program. If they are go with program, then it will be better. Go with steps. Okay, implementation steps, and with one example. Okay, is it so? Okay, one minute. I will connect again. Okay, is it so? Okay, 1 minute. I will connect again. Now it's clear. Hello. Now it's clear, pa? Yes, Mega. Okay, thank you. Okay, so linear search and the case of binary search also, you have to explain the definition. Okay, then in that you have to go with the implementation steps and with one example, then sample program and sample output. Based on the marks, you have to explain, right? If they are asking in 6 marks, then no need to go with all those things. We just go with the concept and one example. If they are asking in 13 mark, you have to explain all those things. First definition and implementation steps and example, then sample program, sample output. Okay. Okay. In the case of sorting, we have two types. One is internal and external. Internal sorting, it is mainly used for main memory. Okay. In the case of main memory, you just want to arrange the elements, then go with the internal sorting. Otherwise, go with the, if that the arrangements need to be happen in a secondary storage, then we can go with the, that is called external sorting. Okay. First one is the bubble chart. What is my bubble chart? One minute. Before going to implementation, one minute. Is compare adjacent elements and swap. Please, all of you go with the. Sorry. My screen is visible, right? Yes. Respond me. Okay. Here, see what this bubble chart. Okay. See here. Checking with the adjacent element. Okay. If the particular element is lesser, the next element lesser, then swapping. Okay. This is the bubble chart. Please listen here. The elements, they are marked in green color. They make the comparison. Okay. And arranging based on that. What's happened? First taking first element and compare with the next element, adjacent element. Okay. Comparing both the elements and arrange these two elements based on the ascending order. Okay. Now the first element is 3 and compare with the 38. Okay. If the 3 is lesser, then no problem, we just leave it. Otherwise the 38 is the first and 3 is the second element means, then we have to swap the element until we go with the last element. We just taking two element, comparing, then arrange based on the order. Okay. In the first pass, this bubble shot is, we have to iterate n minus 1 passes. Okay. That means at a single pass, the last elements only arranged. Here, see which one is the highest element, the 50, right? That is arranged in the rightmost element. Okay. So this is the after the first pass. Okay. Go with the slide, then we will come back. Okay. This is the example. We just having this bubble sort as this is one of the internal sorting algorithm mainly used for main memory. works by comparing two consecutive elements, okay, a of I and a of I plus 1. Each element is compared with its adjacent. Large element in the array bubbles towards the rightmost, okay. Which one is the large element? Okay, it towards the rightmost, rightmost part in that particular array, just bubbling, okay, just comparing and bubbling, okay. The rightmost, the larger element is moving towards right, okay. This is the concept repeated for all pairs, all pair, okay, all pairs till started, okay. And we have to go with, in the case of bubble chart, we have to go with n minus 1 passes, okay. ns is nothing but number of elements, okay. See here, how many elements here? 1 2 3 4 5, 5 elements, okay. We have 5 elements, so we need to go with 4 passes, okay. This is the first pass. That means we just go with that 16 and 17. The first line is nothing but unsorted element, okay. The first line is nothing but unsorted element. We are go with 16 and 17, checking with the 16 and 17, and both are in the highest element in the right side only, okay. What is our main aim in bubble chart? We just find out the highest element, I mean larger element, and try to keep that particular larger element the rightmost, okay. Just comparing the 16 and 17, no issues, right? The larger element in the right side only, so we just keep that same, no change, okay. And we go with the 17 and 7, okay. 17 and 7, then which one is higher, larger? The 17 is larger, right? So we have to keep the 17 here. We arrange the elements, no need to bother about the previous element. Now we are taking the 17 and 7, comparing both the elements, okay. And we arrange the elements. The 7 is smaller one, so we just keep in the leftmost and 17 in the right side, okay. So that means swapping the elements. Now we go with the 17 and 9, okay. And comparing the 17 and 9 and swapping, okay. This is not in order, so we have to swap the elements. Now we go with the 9 will come here and 17 will come here. Now we go with the, how to here bubble chart, we have to go with n minus 1 passes. N is number of element, 5 elements, so we have to go with what, 4 passes. Now the pass 1 will completed, okay. Now you take this element, this arrangement of elements, and go with the next pass, okay. This is the pass 2, the same element 16 7 9 6 and 17. Now the 17, the rightmost element is charted based on the bubble chart. The highest element will come to the rightmost side, okay. So this is the pass 2. Now go with the pass 2 with the same elements which we got in the end of pass 1, okay. 16 7 9 6 and 17, this is the element. Now checking with the 16 and 7, here the elements is not in order, right? So we have to make that particular elements in order, shorted way. So 7 will come to the first position and 16 will come to the second position, okay. Like that we have to do. Next go with the 16 and 9, swapping, okay. This is not in order, and swapping the elements 9 and 16. Then go with that 16 and 6, this is also not in order, so we have to swap the element. 6 will come here and 16 will come go there, okay. So no change in the particular list. After for example taking the 16 and 17, so then no change because it is in order. Okay. So at the end of pass 2, we have these elements 7, 9, 6, 16, and 17. Okay. Now we go with the third pass up to how many passes we have to do? N minus 1. Here we have 5 elements, so up to 4 passes we have to do. Okay. So we need to go with the pass 3. The same elements I have taken, that is 7, 9, 6, 16, and 17. The black color they are arranged. Okay, sorted. So here in the case of third pass, you have to check again, check with the same procedure, go with the same procedure. 7 and 9 both are in the order only, so no need to change anything. And go with the 9 and 6, not in order, right? So we are going to, where we have to do what? Swapping the elements. Okay, 6 and 9. Then go with the 6 and 16, sorry, 9 and 16. 9 is swapped here, right? So 9 and 16, no change. Okay, after that 16 and 17, no change. So no need to go here. In the case of pass 1, we have to do what? All the iteration, n minus 1 iteration. And in the case of pass 2, n minus 2 iteration. In the case of pass 3, n minus 3 iteration. N minus 3 means what? N is number of elements 5. So minus 3, 2 iteration we have to do. Okay. No need to go with all those things. Just here, this diagram just explaining. Okay. At the end of pass 3, we have the elements like this. Now also the elements not in sorted order, right? So we have to go with the pass 4. Again checking the same condition. Okay, 7 and 7, 6, 9, 16, 17. We have to check with the condition. Now 7 and 6, comparing both the elements not in order, right? So we have to swap the element 6 and 7. Okay, the remaining things are in the order only, so no need to go with the here. We just at the end of pass 4, we have the element like this. Is it clear? This is called bubble shot. How we can do this? How we can implement this? We have one for loop for what? Number of passes. If the number of passes is depending on the what? Number of elements. If you are having 7 elements in the array, we have to make 6 passes. Okay, so this next for loop is for number of iteration or comparison inside passes. Okay, number of iteration. Okay, it is first pass, how many iteration? First pass, how many iteration? 1, 1, 2, 3, 4, right? 4 or 5. How many iteration we have done in the past one? 1, 2, 3, 4. Yes, 4 iteration. Okay, that means n minus iteration, n minus 1 iteration. Because of past 2, n minus 2 iteration. Okay, n minus 2 means what? N is number of element 5. N minus 2 means 3 iteration. 3 iteration is enough. Okay, here 2 iteration and 1 iteration. This is the concept explained, done, implemented in this for loop. Start with the j equal to 0 and j less than n minus 1 minus I. Okay, n minus 1 minus I, j plus plus. Okay, this is the meaning for what? Number of iteration or comparison inside the pass. At the first pass, how many iteration? At the second pass, how many iteration? Like that. Okay, the a of j, I start with that 0th for this is for number of passes, this is for number of iteration. So we just go with the a of j. This also start with 0, right? A of 0 greater than a of 0 plus 1, that is a of 1. A of 0 and a of 1, comparing a of 0 and a of 1. Okay, if a of 0 is greater, what we have to do? Swapping the element. For this swapping, we are using this concept. We know already, right? How we can do the swapping, you know, right? How we know or not? This is for swapping, right? We're checking with a condition with the first element with the second element a of j with the a of j plus 1. If both are what the first element is greater, we have to do the swapping. Otherwise no need to do the swapping, just come out of the loop and incrementing the j value. After this condition is over, then we go to we come off the inner loop, then go with the outer loop and incrementing the value. Okay, is it clear? This is the routine or algorithm for implementing what bubble chart. This is a program for bubble chart. Okay, all the things I will upload in the Google Classroom, please refer. It's a time and space complexity. Okay, the same thing for what means we need to go with the two for loops, right? And for example, we have to go with the n number of passes and n number of iterations, so it may take order of n square. Okay, if the elements are in arranged in sorted order, okay, then no need to go with the order of n square, it may go with order of n. Okay, so this is the worst case complexity, best case complexity. Directly we can say average time complexity. I mean complexity for bubble shot is nothing but order of n squared. Within this order of big O of n squared, we can complete the particular bubble shot with any number of elements. Okay, the space complexity nothing but it is taking order of one only. It may take here there we are using one temporary variable, right? Space complexity is nothing but how much how the amount is taken for storing the elements. Array is already taken, I mean n number of elements, it is not a problem. Other than that, we are using any other variable or not? Okay, yes, we are using the temp variable, temp and min, some constant variable we are using, and then it may take the order of one space complexity. Otherwise, if we are arranging we are given one array of elements and doing some process and store the elements with another one array, then the space complexity is order of n. Okay, is it clear? It here it taking it using only one variable other than the array, so it is the space complexity is nothing but order of one. Okay, the next one is selection set. Before that, you please see that website visualgo.net. You please go with that website and checking with that shorting algorithm. Okay, here it can slow and fast that particular process. Just comparing, in the case of bubble shot, we just comparing with adjacent element and arrange the elements. The what higher element will come to the rightmost. Okay, now the second pass is over, the third pass is doing. The three elements in the right side is arranged. Okay, have you understood what is meant by bubble chart? Is all of you clear with bubble chart? We just taking the first element and comparing with the next element. Okay, and arrange that. I mean, main aim is we have to take the larger element in the rightmost side. Yes, okay. All of you, is it clear? Now the elements are arranged. Okay, this is the bubble chart. We will go with the selection start chart. See here first and what they are doing. First fix first element. Okay, and go through travel all the elements in the list. If any element is less than the first element, then we have to mark. Okay, the 2 is lesser than the 3, right? So just we make that this is the minimum element and travel through the list and swapping. Okay, what's happening here? See, selection sort is nothing but we have to fix the first element and travel through the list. Okay, travel through and find the which one is the minimum element. Okay, just selection sort is nothing but this is like in the case of our schoolings, one some will come, right? That means arrange the elements in ascending order. How we can do? How we did that? Arrange the elements in ascending order without any formula. Okay, I didn't give any formula, just to give the list of element and ask us to arrange the elements in ascending order. How will it? How we can? We just pick the smallest element in the list, right? And keep and write that element first, and again and strike the particular element we have, right. And in that remaining element we have search which element is minimum and pick that one. Okay, and after the two element is right, then we go with the remaining element and find the smallest element and pick out. Okay, like that. So here this is the selection start. How we can do? We just go through list of element and find the smallest element. Okay, and pick the element in the front. Pick the element and keep the element in the front. And now the first element is shorted, I mean smallest element is find out and kept in the first element. Now the remaining in that remaining elements we have to shorted. Okay, in this remaining elements we have remaining element like this. In that we have to find the smallest. Which one is smallest? This 3, right? We have to pick the 3 and keep here. Okay, this is the selection start. Just to swap reading each and every elements in the list and finding the minimum value. Which one minimum? Yes, this 3 find out. Now 3 is swapped. Again go with the same procedure. Now the 4 swapped. Okay, the next one 15. Like this way we have to do with the selection sort. Okay, we will see in the next class. Time is over. Thank you students, we will see. Or not. 3 more minutes there, right? Yes, sorry. Yes, all of you please refer with the site and then you'll be clear with that shorting algorithm. Okay, visualgo.net, bubble short selection and insertion, radix. Okay, okay. Selection sort is over. Here also we have to go with n minus 1 passes. Okay, n is number of elements and we have to go with the n minus 1 passes. Repeat until no unshorted element remain. Okay, we will see with a simple example. This is our list having the elements with 23, 78, 45, 8, 32, 56. Okay, this is this dark black line is denoting the shorted and unshorted. Okay, now our whole list is unshorted. We have to pick the smallest one. 23, 78, 45, 8. Okay, 8 is the smallest one. And so we have to go with the remaining things. So then only we can find, right? We have to go through all the elements in the list. Then only we can find the smallest one. We have to go through each and every one and find the smallest one. Yes, 8 is smallest one. And compare this, swap this 8 with the first element. Okay, 8 will come to the first position and 23 will come in the eighth position, where the 8 is present. Is it clear? Okay. Go through the list. First you fix this first element, then go with the 78 is greater, 45 is greater, 8 is smaller than the particular 23. Please mark that. Then again you have to go with the 32, 56 also. Compare with the first element, the 8 is smallest element. Okay. So we just swap the element, 8 will come the first position and 23 come in the here. Okay. Now the 8 is in the shorted order. The remaining elements are in not shorted. This is the pass one. After the pass one, we have the element like this. Then go with the pass 2. Here, my position is here, right? The 72 is here. Then comparing is 45, 23, 32, 56. Which one is lesser, smaller? That is 23. So I just swap this 23 with the 78. The 8 is already shorted, right? So just swapping the element like this. Okay. Second position and 78 will come go to this 23's position. Okay. Now up to this shorted. The remaining elements. So here we have to select the element. Here this is a 43 and 78 and 32 and 56. Which one is smaller is 32 is smaller. So we have to swap with the third position and 45 will come here. Now up to this we have the shorted element and go with the 78, 45, 56. Which one is smaller is 45. Again swap with the 78, 45 will come here and the 72 will go there. Okay. Now this up to this we have shorted element and two more elements are not shorted. So we have to select the smallest from that. 56 is smallest and we'll again swapping the elements. Okay. This is called selection sort. Okay. Is it clear, all of you? Bubble sort and selection is over. We will see in the next class about radix, insertion, shell sort. Okay. Thank you, students. You can leave. Yes, thank you, Sandeep, Isak, Rajalakshmi, Meega. All of you, please complete your assignment and skill track. Okay, thank you, Pa.
Good morning, students. Good morning.
Good
Still,
morning, ma'am.
ma'am. Good morning, ma'am. Still recording going. No one stopped.
Even I also didn't notice, madam.
Yes, yes.